Okay, so I'm going to be explaining XRTA 7A through D. And essentially we just start with 0.55 kilogram mass oscillates according to the equation x of t equals 0.38 cosine 14t. And the position is t in meters. So the first question is asking what is the period in seconds of this mass? And first we start off with A equals 0.38. And the way that I solved for period is I found the frequency first, and then I did 1 over the frequency gives me the period, which is a known formula used. The other known formula is 2 pi equals times the square root of m divided by k. And essentially I used the formula for frequency, and I had f equals angular velocity equals 2 pi, and what I did was I just manipulated it to find f, so I just divided that by 2 pi, I just did that. And so I got 14 radians over 2 pi, or 2.2293 hertz. So then, after I found that value, I did 1 over 2.2293, and I got this value right here, 0.45 seconds. Next, it says, what point is mass moving at max speed? And I chose equilibrium points are at the middle of the cycle. So in regards to max speed, they're at the middle of the cycle. And then for max acceleration, it's different, but I'll explain that down the road. So for C, it's asking what is the maximum acceleration of the mass in meters per second. I started with this diagram right here, which is just a spring oscillating, and I have the formula A equals F divided by M. So F equals KX, because that's the force value. So then I manipulated it and found A equals F net divided by M. So A equals KA divided by M. And then I used my values and plugged it in. So I said 0.55 times 9.8, which is just mg. Mg is a known thing in physics, so it's just because there's a downward force, we're going to use mg. And essentially, mg is just the force. So then I divided that by 0.38, which is A. And then I got 14.1842 times 0.3, which is the known value. And then I plugged it into this formula, which is a formula for period. And I manipulated this so that it's solving for k, which k is inside. So then how I did that is I did this. And I could show this, but essentially this is something that we were going to be doing throughout the unit, and I showed it in my last screencast. It's just you do the relative number theory, where you put 1 for each, and then 2 by the relative at which it changes, like the constant at which it changes. So I got k equals 4 pi squared times 0.55 divided by 0.44851 squared, and I got k equals 107.8. And then I have A equals 107.8 times 0.38 divided by 0.55, which gives you this value right here, 74.48 meters per second squared. And then number D is asking, or letter D is asking, at what point will it reach its max acceleration? So max x is the displacement of the cycle, is what I chose. And essentially this is what it means right here. So max acceleration is 0. When attached to mass, it is at its maximum. So essentially its acceleration is 0 when it's attached to its max at its maximum. So it's at its maximum when it's at 0. Unlike the speed that's at its maximum always in the middle. The speed is always at max in the middle. So that is something to keep in mind because it will never change. And essentially that is the difference between max acceleration and max speed. That is a look at number 7, A through D. Thank you.